I do want to talk a bit about T-SQL code analysis. Just a real quick recap. I work at Microsoft on that Azure Data team with Anna Hoffman. My focus area is with SQL development. I did a master's degree at Georgia Tech recently, and some of that nerd is going to come out today, and that'll be a lot of fun. You're welcome to connect with me on LinkedIn, especially if you have follow-up questions today. I'm happy to chat. Recently, I asked folks are you looking to control or try to monitor the SQL code quality in your database and applications? There were a lot of great talks today about improving the workflows that we have as developers, whether it's what people are doing or automation around things. How do we make sure that the applications we build are reliable and work well? For SQL code, the the paradigm of SQL being separate from the C# or the Java or the Python or other application languages or writing, it being separated kind of bites us a little bit with disadvantages. We might think, oh, the ORM is creating the database objects for me. EF Core does a great job, but is it perfect? Do I need to double check? Maybe someone else is responsible for the database. There are DBAs that are going to make sure that the database is working well. So I don't need to worry about that. And my personal favorite is it runs fine on my machine. The query is super fast. I know that it's going to return the right results, so we're good to go. Maybe you're the only one who knows the database, kind of back to that, my code is perfect. But we can never be too perfect. So if we think about the database is truly part of your application code, and you want all of your code to consistently have good quality. We don't review 500 lines of C# code only to ignore the 50 lines of SQL code that go along with those stored procedures. So to that end, what we're going to talk about for the next 40-ish minutes is how can we bring SQL along for the ride into ensuring code quality. I've got 3 things to touch on. The first one is a really cool project called SqlCheck. The second is a .NET library called ScriptDOM. And then the third is a whole development paradigm that leverages ScriptDOM and provides a whole world of code analysis opportunities. SqlCheck is a graduate project of now Dr. Joy Arulraj at Georgia Tech. This is available on GitHub, and it's database agnostic, so that's a huge advantage for it. If you have a SQL script like this, the way SqlCheck works is that it is a command line interface that when you run it will provide some text output. If I run SqlCheck against this create table statement, it's going to give me 3 results in that text output. The first one is there's a high risk around the primary key just generically being named ID. We'll come back to that concept in a minute. And then the next 2 are more general hints around as we write queries, we want to be careful in using null and not null statements. As a general practice in writing SQL code, it can be really helpful to have a CLI like this that we can pass a SQL script and it can give us some feedback. SqlCheck is really cool. Some of the nice things about SqlCheck itself is that it's compiled from C++. So as far as the speed that it has, it's quite quick. This also means that it's cross-platform, and you can compile it yourself if you have a really specific environment where you need SqlCheck or your code analysis to be running really quickly. It's open source, and the code structure of it is in such a way that it is effectively extensible. It is not extensible in the way that you write an extension for it, but is extensible in the way that if you pick up the code yourself, you can write additional rules. The things to be aware of when you're thinking about SqlCheck and passing it your SQL scripts and using it is that it is based on regex string matching. I am not great at writing regex, so this commentary comes from that place. If you are a regex master, if you're an aficionado of regex, maybe you can write the string parsing that you need to perfectly match individual statements. But there are some things that we want to watch out for with regex parsing that we'll take a look at in a second. The other limitation that I want to point out with SqlCheck is that it's outputting text output. And so unless you parse that text output, you can't necessarily do anything if you have that inside of like a CI check for when you open up a PR. So instead of having an API surface area, it does do text output. This makes it really easy to pick up and start using, but it does present some limitations as your environment gets more tricky. So if I step into VS Code here, I have the SqlCheck tool, the whole source code downloaded. I've built it locally here on my machine, and so it's installed. So when I run SqlCheck, I'm going to use the C flag to get colorized output to make it easier to read. And then I'm passing it the file that's open here on the top. I'm going to expand the terminal just a bit. And we're going to get similar results to what we saw in the PowerPoint. I removed the not null flag to simplify the results just to make this example easier to follow. But I have a risk right now that my ID key is too vague. When I need to join this table to another one, it's going to be tough to track that. So maybe we would want a more specific name. Being a developer that is more familiar with SQL Server and Azure SQL, I oftentimes see square brackets around my column names. So when I do that in this SQL script and save it, and then run SqlCheck again, I find that, unfortunately, this time, it didn't pick up that the ID column is blank. We would need to modify it to do that. Now we can get around that by now doing some really ugly things with the column name, like adding spaces around it. So the column name is technically space ID space. No one's having a good time. But to kind of take this example too far, let me say, hey, the column name is actually ID space, not space null. And when I run this again, now I'm getting hints about not including null and not null expressions when it was actually part of a column name and not a column specification. So when we use regex parsing, it is extremely helpful. It can give us really good insights into our scripts. So if I have not null column, it's going to correctly tell me this time. You don't want to be using that on line 4. It's really specific. It tells us where to look. It's extremely useful, but it has those limitations that as your code base gets larger, you might want to move past that. So check out SqlCheck, see if it's helpful for you, but I do want you to know that there are additional options. If we don't do string parsing, how do we process our SQL to make sure that it's good? We know we can throw it at a database, and the database will tell us, yes, this is valid, or no, it's not. We can do that kind of integration test, but I want to know if it's good. What do we use for that? This is where syntax parsing comes in. Syntax parsing is a concept that exists across all code, all application code. So C# has syntax parsing that brings you IntelliSense and linting in the editor. And the same thing exists for SQL code. It gets a little bit more difficult because there are different flavors of SQL code. There's PostgreSQL and SQL Server and MySQL, but it does still exist. Why we like syntax parsing is that it can output to us an abstract syntax tree. I promised we would nerd out a little bit today, and here we go. An abstract syntax tree gives us a linked data structure, or a tree, as the name suggests, of what the code represents. There's a SQL Explorer abstract syntax tree tool that I use, and I've linked at the bottom of the slide. And when I pass that the example query that we were using with SqlCheck before, it'll help me branch out and see what are the elements of that syntax tree. So within the tree at the top level, notices that we have two statements in our SQL code. The first one is the first line where it says drop table if exists. That one is collapsed in the Explorer. And then I've expanded out the create table statement where I have a couple different keywords, the create keyword, the table keyword, and then an identifier for the name. So we can see where we can more specifically access parts of our code in a way that we can check things about it. So ideally, we have a syntax parser that we can pass our code to and get an abstract syntax tree out that then a code analysis engine or a compiler can do better testing with. And in this example on the right, I have highlighted in yellow that column name for ID. We could be checking that in the world of we're looking for columns named ID. For abstract syntax trees, one way we can get them is through that ScriptDOM library. Now, this is a .NET library. So for those of you, the probably decent handful of you on this call that are comfortable with C# development, .NET development, this may be right up your alley. It is available for .NET Framework. It's also available for .NET 6 and 8. And what this library does is if you pass it one or many SQL scripts, it parses them into their abstract syntax tree representation. It represents the SQL Server and Azure SQL syntax area. What is especially interesting about it is not limited to just object scripts. You can do some of the administrative scripts with it as well. So if you're in an environment where you're worried about metadata or management of SQL, you can also use ScriptDOM to keep an eye on those scripts. Something that I'm very proud of the team for is that we did open source ScriptDOM back in 2023. And so it's available on GitHub, both for you to kind of take a look at, but also interact with the team. If I have a SQL parser like ScriptDOM, what do I do with it? How do I use this library to get more information out of my code? For that, I have a quick example. We're going to take a file. We're going to go into this code here that's on the screen, and we're going to take a look at a query, and we're going to check it for two things. First, I want to make sure that the developers on my team aren't doing select star. If we have components in the code, we want to make sure that we're not getting any unexpected columns or we're losing columns, which can happen if you do select star and the objects underneath the query change. So I want to avoid select star. I need to be able to catch that. The other one is the no lock hint on tables can sometimes get used like finger painting in queries by well-intentioned developers. I also want to avoid that from getting checked into code. And so I want to go ahead and be able to catch both of those anytime a SQL script gets parsed. So if I go back over to VS Code, I'm going to start with a query here. It is parsing out a table. It's just a sample query where I've declared the current year is 2024. And I'm selecting a bunch of columns from a table, including select star on the end, because I just want to be double sure that I'm getting all these columns. This is not a pretty query. The project itself is just a plain old vanilla .NET console example, but I have picked up the package reference for ScriptDOM. This is the important part where if I want to leverage that library, I need the package reference. And now in my toy proof of concept here, we have a little bit of code where in the main method, I'm going to ask for a file path. And when I open up that file path, we're going to use the surface area, the API surface area of ScriptDOM to do a few things. The first thing is we're going to declare a parser. And this parser is for T-SQL 160. If you're not familiar with the SQL versioning, it's a little bit weird. And T-SQL 160 represents the SQL 2022 surface area. So I'm saying I want to make sure that this code is valid for SQL 2022. I could change it back to SQL 2019 and make sure that I'm not suddenly getting things that aren't supported. When in the next line, line 26, go ahead and parse the file that's been read in, the first thing ScriptDOM is going to tell me is whether or not it can be parsed to a valid syntax tree. So right off the bat, I'm already getting error checking, so I could output those. Because I know that my SQL is always nearly perfect, I don't expect to have to use that catch block today, but I am going to do something called a visitor pattern, where T-SQL fragments that are found in the syntax tree can accept, where we see tree.accept, can accept overrides to a visit method. What this looks like is when tree.accept is called, each statement is checked for whether or not it's going to be able to accept that visitor. The select star visitor can only be accepted by select star expression. So there are different classes for different kinds of objects in that syntax tree. One of them is the select star expression. Another is a table hint, which represents the with no lock clause. We could do this for a column name or a table or an index. There's all kinds of different classes that you can find in the .NET API documentation. In this example, when I run it in a moment, we're going to be passing the abstract syntax tree for that query to a select star visitor that's going to tell us whether or not it finds a select star expression. And then we're also going to pass in the no lock visitor. The select star visitor is the most bare bones one possible, where it's just only going to be accepted by select star expressions, and then it's going to output a line. You can do more complex operations in these visitors. Not only can you manage kind of control flow by saying, hey, I want to check the hint kind and make sure it's a no lock table hint, but you can declare objects and accumulate information. Like, you can only have one no lock. You can't have 5 within a single query. Then I know you're really not paying attention. You can do all kinds of things like that. Keep in mind, right now, this query does not have a with no lock clause. So we should expect to see that it parsed the query correctly and that it finds a select star expression. And let me go ahead and copy this path real quick. Do .NET run, and then when it asks me for the file name in a moment, I'll give it that file path. So it said no errors found, but it did find a select star expression. If I do with no lock, it's going to find a no lock hint. Now, here's the thing that I hammered home earlier. The very specific syntax matters when you are doing regex parsing. But what about for syntax parsing? When I'm not doing string parsing, but when I'm doing syntax parsing, now I can kind of mangle this no lock table hint up. There's a number of different ways that are technically accessible. And I'm going to run it again. And so I've removed the with, but it still says no lock, which is a valid table hint. And it did not find it that time. So what did I mess up? I love it when things don't work like I expect. That was awesome. There we go. So I had broken the table hint by not including the parentheses around my list of table hints. Once I put the parentheses back, we were good. Now I have to go file a bug that it didn't throw on the no lock. You get more robust syntax parsing when you use a syntax parser. One of the reasons why we wanted to open source ScriptDOM was that the surface area for SQL is always changing, and we wanted to be more open to people bringing us issues that they find. Yeah, Jake is helping me out in the chat and reminding me that no lock is a valid alias, so it should have been okay without those parentheses. So I get to go work on that later this afternoon. So when we use ScriptDOM, we're able to use visitor patterns to catch different parts of the syntax tree and then react to them. You can do more extensive things. One example that I've seen more recently was taking the SP execute SQL expression where you're using SQL to execute dynamic SQL and find what is actually being executed within that without having to run it. That is another way of using the syntax tree and then kind of decompiling it from there. Let's head back over to our example. With our kind of quest towards code quality, we know that we want code analysis, code quality to be a part of our process. And that's where I introduce CI automation as just something to keep in the back of our minds. Today, we are not going to go build out a PR check pipeline, but what I want us to think about is when I check some code in, we do a few things like making sure that it can build. Sometimes we are using unit tests and .NET Test, or potentially we're generating migrations with EF migrations. There's all of these pretty common things that we know need to happen. In the SQL world, we do have one thing that's analogous to that, and that's the concept of a SQL database project. These are a little bit of a divisive topic sometimes because the most common way that they are used is in the forward direction where you're building your database objects specifically in a database project, either in Visual Studio or VS Code, instead of using an ORM like EF Core to generate your objects for you. This is not to say that you can't use them in conjunction with an ORM. It just is not a very common pattern, to be honest. But the database projects have, similar to C# projects, a build process where then they have a build artifact, which is a DAC pack. So now for SQL, we have two kind of tools in the back of our tool belt. We have the ScriptDOM syntax parsing library, but we also have a database project that has a build process. So can we link our ability to parse scripts with the fact that we have a process where we're going to be building and validating our database objects? When a database object builds, or when a database project builds, it looks at all of the objects in the scripts that are defined as a part of that project and validates their relationships. It makes sure that if a table has a foreign key to another table, that that table actually exists, that that foreign key actually exists, for example, or a stored procedure, if it's calling to columns in a table, do those columns actually exist? That kind of check is happening. Can we extend this to making sure that the code itself is not just valid, but that it is good? And this is where code analysis can be enabled on SQL projects and take us that next step. The term that's sometimes used in the code analysis world is anti-patterns. I hesitated to put the term bad code on this slide because some anti-patterns, you have to do them. There's not a better way around it, but you at least want to know that you have done this. And that is why when you enable code analysis rules, you can go two different routes. And for specific rules, which we'll talk about in a second, you can either go to a feedback to the developer where it's just a build warning. We're familiar with build warnings developing with C#, or you can go all the way to a build error. Let's say you absolutely ban nullable columns. You can block builds on an error if a nullable column is detected. So that is an option. As far as code analysis and kind of just running with it today, if you have a SQL project, there are out-of-the-box rules. In Visual Studio, there's the nice project properties pane. And in the project properties pane, you have the code analysis tab where you can checkbox to enable code analysis on build. This sets the project file property for run SQL code analysis to true. and that just gets it going. By default, the out of the box rules are set as warnings. So you're not going to break your build by doing that first check. You can enable and disable specific rules out of the box. There's about 15 of them. There's some more around database design. So that select star example we hammered on earlier. You can start getting picky about how objects are named, perhaps avoiding using reserved words for type names, things like that. And then last but not least, there's a whole performance category where we make some suggestions around how to improve your performance. So if you were coming today hoping to find out how do I write really good performance SQL code, I am not the person that's going to make those final recommendations for you, but here's tooling that, while there are a handful of rules here, in a moment we're going to talk about how can we go further on these rules. So if I've enabled some rules and then the specific ones that we want to serve as warnings or as errors instead of warnings, when we check that, we will also get a project file property that has that plus exclamation point and then the rule name. As you look at that rule name, it is not a mistake if you're thinking, geez, that sounds a lot like a class in a library. Because in fact, code analysis rules are a library and it is extensible. The way that the code analysis engine works is that it will load up all of the rules that it can find, which is a very weird way to phrase things, I understand. I promise I'll come back to the idea of the code analysis engine finding rules. When you are running code analysis rules, like during a SQL project build, you can incorporate rules either from a community project or from your own knowledge base. So if you've got specific rules for your development environment, you can write those rules yourself. But you can also adopt rules from a couple different community projects. There's SQL Server .rules, and then there's also T-SQL smells. Both of those are really cool projects where they spent a lot of time and took input from a number of developers to put together over 50 rules that can be pretty helpful. What's important to understand about writing code analysis rules is that the object definitions and the relationships are accessible while you write them. So keeping on theme with today, it's not just about parsing the strings, but you can go to the level of looking at every table and throwing a warning if a table has no foreign keys. It's possible that you have some tables that are completely unrelated from others in your environment. But that is the kind of thing where you can traverse the syntax tree as well as the relationships between them to test that out. So the relationships between them come from the DAC model, and then the syntax tree comes from the ScriptDOM parsing library. So you kind of get both, 2 for 1 when you're using this code analysis extensibility. The rule configuration that's a part of this was what we saw on the previous slide, where you get to check for whether or not rules are enabled and disabled, as well as if they are an error. And then the concept of picking up all the rules for a target platform. That is a special one. So let's take a look at using code analysis rules in real time. Now, you already know I work for Microsoft, so you're not surprised to see me using AdventureWorks. In this example, I'm in VS Code, and I'm using not the SQL projects that are currently available in Visual Studio. I am using SQL Projects SDK. When I build this project, it's going to run SQL code analysis, and it's going to run SQL code analysis with some specific settings. First, you see the minus example. It's going to skip some of the out-of-the-box Microsoft rules. I've loaded in T-SQL smells rules, and I'll show you how I did that in just a second. And I've said I want these rules to be considered major issues. So if I do a .NET build on my SQL project, which again, just a quick review on what a SQL project is, it's a definition of all the objects that I want to be declared in my database, and it compiles them together into a single build artifact. To deploy that build artifact, you would use tooling like the SQL package CLI, or within VS Code and Visual Studio, there's a publish button, but likely you're automating. You can generate even a deployment script. While the concept of writing all those create statements can be a little scary, because you're thinking about like, now how do I update my database? That's what the SQL package CLI does for you, is it generates the deployment of figuring out how to make those changes. That's beyond us today. We want to focus on, I have my object definitions. How do I make sure that they're good code? When I run .NET build, it's going to take a look at all of the relationships in the database, all the object definitions, and then it's going to run the rules that I have enabled. And smells 005 is, again, the select star rule, and it found that. And it found it in a view that I named select star. That was very clever of me. And even tells me what line and character it's on. So if I go into views, select star, it's on line 3, character 8, and there's my select star. So if you have a huge code base and you want to start improving it bit by bit, enabling code analysis will tell you where to look even when it finds these issues. Now, loading in custom code analysis rules is going to look from where the build engine is loading the DAC effects DLLs from. For Visual Studio builds, that's a specific folder within the Visual Studio installer folder. For the .NET SDK, we have a very interesting road ahead. So first, the workaround. Right now, the build pulls its targets from the build folder in the NuGet folder. So if I go into packages and drop my compiled DLL for T-SQL smells in there, I'm able to go ahead and pick up those rules. They're just picked up automatically. No further steps. Now that's still not as good as we want it to be, because again, our idea with SQL code analysis is that we're getting SQL to be just as a part of our development process as the rest of our application code. When I need to pick up development dependencies for my C# projects, I add package references. The direction that we're headed, and it is not there yet, is to have a package reference for different packages like code analysis. Let me go back to the deck real quick, because I want to kind of close out by wrapping up where we're at in this SQL project's evolution to bring code analysis to a better place. First, I want to start by recognizing that there's a fantastic community project for SQL projects that's been really setting the bar for how do we make it as easy to use as possible, especially in cross-platform environments. And it brings in the very extended code analysis rule set just right out of the box. So if you're looking for like, how do I get started today with the least amount of friction, picking up the msbuild.sdk.sql proj is one way to be able to take your SQL project and get a larger rule set on it right away. The other thing that the community SDK for SQL project at the top introduces is package references for DAC packs. If I have a large database and I need to break it apart, one of the ways to do this is to publish DAC packs as NuGet packages and then pick those up into a SQL project so that you can have a better architected database. Now, package references with SQL projects is a fantastic concept. And that's why I mentioned before where we're bringing code analysis references for SQL projects is that instead of needing to do that ugly workaround you saw where I had copied the DLL for the T-SQL smells into the NuGet packages folder, this should also be a package reference for custom rules. You can do that for DAC packs as well with that Microsoft.build.sql SDK. But it needs to be a package reference to make it even easier to bring in those additional custom rules. The Microsoft.build.sql SDK that you saw me using with AdventureWorks is an evolution on the original style SQL projects. If you're an aficionado of SQL projects, you probably are quite surprised at how short this file is. The default globbing of all the files, for example, is something that's a part of both SDKs. And so it makes it much easier to modify and edit the SQL project file. And so this will be coming soon into Visual Studio. Overall, when it comes to code analysis extensibility, it's not required. You are already going to get a win if you start in Visual Studio, enable code analysis on build, and just start getting warnings when your code needs some improvements. But if you want to take it further and either load in community rules or you have specific requirements for your own environment, this is where you can use community examples or follow the walkthrough in the Microsoft documentation to write custom rules or rule. Like even if a single rule will help your environment, it's worth it. Have those custom rules. You get the analysis results as a part of a build. So that becomes part of your CI, and then you're all set. This is one of the best times to be hopping in on code analysis for SQL because we are bringing package references for custom rules to that build SDK right as it starts to land into Visual Studio very, very soon. So it's like best timing ever. With that said, we covered a whole breadth of topics today at a surface level. I'm happy to take any questions if folks have it, but we started with SqlCheck and looked at how even regex parsing can give us valid feedback on things. There are edges to what it can do, and that's why we like to head towards syntax parsing with ScriptDOM, which is a .NET library. You can use it standalone, like you saw in that console app example that I had it parsing scripts. I even got my demo to kind of slap me back in the face a little bit where it didn't recognize the no lock alias in one way. So now you get to see that pull request out in open source here soon. And then last but not least, SQL Projects brings code analysis as just a checkbox on build so we can get those warnings in real time as a part of our CI.